there? So we are going to be discussing physics, and the topic is what now? Motion. Right there? Now, motion, you can see the way I'm starting like this. I've not started moving, right? So the moment I start moving, it means that my body is what now? Is in motion. Right there with me? Because I was able to change direction. Okay, now look at what I mean. Look at I'm moving. Remember this was the initial position, right? Yeah. This is the initial position of where I was. I mean, if I apply a force, I am now moving. Right there, look at it now. I think I'm moving now. Look at where I was. Look at where I am now. That means what happened is I was able to change position from A to B. Now, of course, you know that as anything you are doing in this life, time must always count. Is it true? So because time is going, it means that motion is the change of position of a body. In physics, anything can be a body. A cup can be a body. A market can be a body. So body in physics does not necessarily mean human being. Anything can be a body. Chair can be a body. Blood can be anything can be, even your scuba can also be a body. Are you with me? So we say that motion is defined as the change of position of a body with time. Change of position of a body with beginning. Then we now say that what causes motion is what? Is force. Now look at it here like this. Am I moving? Now the only thing that will make me to move is when I apply a force. If I apply a force, that is when I can be able to move. You can see I'm not moving up here because a force was being exerted on this body. So if I don't apply a force on this body, nothing will make me to move. Are you with me? Well, then I'll forget. Boy, you can write. This one hand and write, bro. Okay, why? Okay. Idea. Okay, add. Can you do this work? Okay, why give her.
What's it?
Okay. And a smart force. Look at that. A body will continue in its state of gaining rest unless being acted upon by gaining. And what it means, look at this book here. Look at this book. If I place this book on this place, look at, are you seeing the book? If I place this book here, everything being equal. If I come in the nearest future, everything being equal. If I come in the nearest future, I can maybe next year or next week, I'm going to still see this book there. Unless an intruder enters here, maybe either a thief or maybe somebody will say, this book, he cannot be here, the person will remove it. Now, when any attempt to remove this book, what have I applied? I've applied the force of here. So, what you can see, this object is it moving? Is it moving? No. So, what will make this object to move is when a force is gaining. And if a force is applied to a body, the moment that body starts moving, that time is called gaining motion, okay? Because motion is always the change of a position with gaining time. So, whenever your position is changing, it means you are undergoing what now? Motion. Are you with me? Okay. Now look at the equation of motion. Equation of motion. I don't have time to prove all of them. We don't have so much time to start proving all of them. Okay? But look at the equation of motion. I'll just state it, so I will just start solving. Okay? Now I know that A, acceleration is equal to change of V over T. Acceleration is what now? Change of V over gaining. So that means A is equal to change of V means final velocity minus initial velocity all over how many now? I will do over 1, I will cross multiply. I get? U minus V times that one is what now? V minus U. Then equal to this times this is what now? H of here. Can this one come here? So V will now be U plus A what now? So this becomes your dangerous formula what now? Activated. I will call it equation gaining 1. I get? Dangerous formula what? Activated, I will call it what now? Equation 1. Is it equation 1? Okay, if it is equation 1, I will still recall, I will still continue. I will still continue by saying that average speed is equal to U now plus V over 2. Now, you know what you mean by average speed? Class, you know what you mean by average speed? No. Okay, now, when you talk of speed, we know that when they say average, for example, when they say average, it means if I want to find the average of your age in this class, what am I going to do? The first person, maybe all of us who are here, assuming we are 15, and you know in these 15 persons now, we are going to have different age range. Is it true? Maybe the first person it is possible the age is 12 or 13 or 15 of here. Now I'm going to add all your ages and find it by how many now? Do you get it? That is the average. So now because I have initial, now look at it here. If I want to start a journey, they say on your mat. They say on your mark, get set. At this point now, because I have not started moving, this one becomes my initial gaining velocity right there. Then when I start moving now, this one becomes when I complete my journey, that place becomes my gaining final what now velocity. Okay. So if I want to find the average velocity, it means initial velocity plus final velocity all over again. So why am I dividing by 2? Because what I have there is how many velocities now? Are you with me?
Yes.
So I will say that average speed is equal to u plus v over how many now? I will say but. Mama, I will call it equation 2. I will say but. Mama, what are you butting? Okay, but. Average speed is equal to the total displacement or total distance, idea, all over time. All over what now? Time. Okay, so this one is everything here is okay. This one is V average. Look at it. V average is equal to S. Total displacement is S. Then this one is T. Okay, I will do over one. I will cross again. S times 1 is S, and this one is V average. Idea does what now? What is? I will call this one equation what now? I will say put equation 2 into where? Into where? Into 3. Carry it and put where? So that means S is equal to V average is what now? U plus V over 2 all multiplied by what now? I will call it equation again.
4.
Are you with me? I will call it equation what?
4.
Is it equation 4? Class, is it equation 4?
Equation 5.
No, it's 3 man.
2, 3, 4.
1, 2, 3, and 4 now. Okay? Okay, now because of time, let me just get to the other ones. Idea, we have that S is equal to UT plus half AT square. Then we have that V square is equal to U square plus 2A what now? X. Okay? So these are the major equations. We have, okay, let me state the first one. V is U plus AT and S is equal to U plus V all over 2 all multiplied by what now? So all of these are dangerous formulas what now? Activated. Idea? I will say where, what are you wearing? That U is equal to, sorry, let me say U is equal to initial what now? Initial gaining, all in meter per hour. Then V is equal to what now? Is it final velocity? Open your mouth and talk to me because your confession is your possession. Whatever you confess, you possess. Are you with me? If you confess A, you possess again A. Okay, A is equal to what? Is it acceleration? All in meter per gaining. Then what of our T? Is it time? All in gaining. Then what of our S is equal to what now? Displacement. S is what? All in gaining. So these are the parameters we have. Important code. Let me
So I want to ask you a question.
Yes.
This A now, it can also be used as retardation.
Yes, retardation, yes. You know what I'm not saying, especially you're talking of the increasing rate, okay, increasing rate of change of velocity. Why retardation, look at it here. If I have this man, look at acceleration, increasing rate. Okay, this one is accelerating, okay? Then when it is now coming down, it is what now? Decelerating, okay? Or we call it retardation, okay? Or negative acceleration, okay? Because why is it negative? Because it is working against gravity. Okay? Anytime it's working against gravity, it must be what now? Minus. I mean? Okay, having said that, let's go down to important code. Have you seen important code? Okay, here's what is number 1. Number 1. Important code. Number 1. Give that one. Continue with number 1. Important code. Important code. There goes something. Let's go to number 1. When a body, look at that, when a body, important code, when a body, idea, when a body starts from rest, look here. When a body starts from rest, yes, comma, the initial velocity, u equals to 0. The initial velocity, u is equal to how many now? 0. When a body starts from rest, the initial velocity, u equals to 0. The initial velocity, u equals to again. So that means anytime you want to solve any surface equation, any equation of motion, and you hear a body start from rest, you don't need your grandfather. Neither do you need your pastor to tell you that u is equal to again. That's why I said it's important. It is a code. You know, when something is encoded, they might encode it in word. They might encode it in symbol, okay? So you're able to capture the intelligence to be able to know what to do per time. Yeah? So in order to hear some of all this information, you should be able to know what to put. Okay? I hear a body start from rest. I know that u is equal to again because in the question they will not tell you that the initial velocity is equal to 0. So once you hear the statement, now let me give an example. During inter-house, I want to run maybe 100 race. They will draw a line up here. Then all of us are going to stay according to our what is it called? Houses up here. Then they are going to say on your mat. On your mat. Now in this on your mat, at this point, you know I'm almost vibrating up here. What I want to hear is what now? Is the whistle, right? The moment I hear the whistle, what will happen? I will start running. So at this point, because I have not started moving, it means my initial velocity is equal to getting 0. Are you with me? So a body start from rest means I am sitting from getting rest. That means I have not started moving. That is the implication there. Are you with me? Hey, go to number 2. Number 2. Hey,
The person is still calling.
Number 2, yeah, give it. Number 2. Number 2, again. Number 2, take something. Number 2. Alright, go down. When a body comes to rest, comma, look at it. I am coming to rest now, comes to rest, comma, stops. Stop also. It again. Stop also. Comma, or brought. Look at that. Or brought to what now? Or brought to rest. Comes to rest, comma, stops, or brought to what? Rest. Comma, the final velocity, comma, v equals to 0. Look at that, v is equal to 0.
A final.
Yes, the final velocity, comma, the final velocity, comma, v equals to 0. Don't hear through your bum, here with your ears open. And then I say the final velocity, comma, v equals to how many?
0.
Are you with me?
Yes.
Go down. Now, look at it again. On your mat again, camera in here, on your mat, now they are going to draw a particular line this way, and the way they are going to stop. Is it true? Now, when I start running from here, if I start running from here, the moment I exceed this point, I don't. Now, even if I continue running, the person in charge, the instructor, will not going to count it. Is it true? Idea. So what they want to observe is the first person that will reach this line. Idea. The first person to reach there becomes the winner. Idea. Now you can see at this point now what happened. I have now the motion have been brought to rest, right? I stopped. I've been brought to rest, and I came to rest. Are you with me? So when the body comes to rest, it means that the final velocity is visible to how many? Number 3. Before we start on number 3. Hey, number 3, mama. Number 3. The devil. Hey, when a body moves, it doesn't move with uniform, move with uniform or constant rotation, with uniform slash constant rotation. On the board, velocity when a body move with uniform slash constant rotation. Velocity, its acceleration is equals to 0. Its acceleration, comma, a equals to 0. Its acceleration, comma, a equals to a. Now, anytime you hear constant or uniform velocity, it means that the body is not moving. So it means that v is equals to a. So if v is equals to 0, I know that the formula a is equals to change of v over t over here.
Yes.
So a is equals to change of v is now getting all over time is t over here. So anything besides 0 is equals to getting. So a is equals to what now? Oh yeah, copy. Oh yeah. Do for watch it. Full mouse. Watch it. Who made it just that? Watch it. Well done, let's go. Okay, so we are done. We are going to now start sorting. Pause.